Good evening, everyone. And once again, my name is Susan Watt, and I'll be your moderator tonight. I'll just be in the background, so if there's anything you need, you can let me know. A welcome to all of you from across mostly Southern Ontario, but also from Berks Falls up in the north. So welcome. It's really nice to have you all here on this spring. Hey, spring, first spring webinar for OTF Connects. I'm really happy to welcome Maria Van Vallis tonight. Maria and I have worked together here in this platform before, and I know she's going to have a lot of great stuff to offer you. This is a wonderful topic about nurturing quality thinking in mathematics. Maria works with the Critical Thinking Consortium, and I know that she's going to talk a little bit more about that organization and their focus and how you can get involved with them as well. So Maria, a really warm welcome. I'm looking forward to this session, and I know everyone else is as well. So I'm going to turn off my mic and turn things over to you.
Thank you so much, Susan, and welcome to everyone. I see some familiar names, and it's great to be back here at OTF Connects. Just a little bit about myself. I've been teaching for over 16 years now, and I do teach across grade levels, and I'm an interdisciplinary teacher. So I always talk about the fact that when I started teaching mathematics, I was someone who had an interest in mathematics, but certainly some of my other teachables were more prominent. And so at the elementary level, I had to really spend a lot of time thinking about how I had learned math myself. And this started a real journey for me because I wasn't completely satisfied with my own experiences. And part of that has really been this profound growth opportunity and growth mindset for myself. And it's always a real pleasure for me to be able to work with Ontario's dedicated educators to learn with you and to share, because I know that we're all really committed to this important job that we do. Sometimes when we stop to think about it, it is quite daunting, right? That the experiences that students are going to have with us in our classroom can really profoundly shape their lives in different ways. The one thing about teaching is that we spread seeds, and we don't always know, how those seeds bloom in the world. So tonight I really invite us, as teacher practitioners, as instructional leaders, to spend some time in a reflective community, really thinking about our practice and just thinking about what are some of the things we might do or that we might try as we're trying to nurture more intentionally quality thinking with our students. So I wanted to ask you, what's one of the most effective things that you already do to nurture quality thinking in mathematics? And feel free to either write on the slide itself, or grab the mic, or type in the chat box, whichever you feel comfortable with. We've got a smaller group tonight, and one of the real positives of a small group is that we do have some opportunity to really hear from people through the mic, as Susan mentioned. So what's one of the most effective things that you already do to nurture quality thinking in mathematics? So give interesting problems, letting kids talk and really listening when they talk, number talks, really, really wonderful ways, to nurture and to surface, right? Surfacing that thinking is so important for us to know what it is that's happening with our students. Jane talks about promoting discourse through worthwhile tasks. Heather asks students to make conjectures, to not say math sucks. Yeah, absolutely. The problem-solving opportunities and engaging in the math talk. Real-life connections. Building problems from real situations. Allowing for a variety of manipulatives to be available. So again, everyone here is really thinking about what it is they're doing and trying to engage students. And tonight I want us to spend some time, I'm going to come back to this word, but being very intentional. Being very intentional in the kind of interesting problems that we give. Being very intentional in how we might facilitate a number talk. Being intentional about the way in which we're asking students to collaborate. So that in the course of that time period that we're with our students, what are some of the things that we can do to really bump up and really nurture that quality thinking? I wanted to ask as well, just using the tool that Susan indicated, how many of you have been in a session with the Critical Thinking Consortium before? And if you just want to do a green check for having been in a session before, and an X if you have not. Okay, so we have a number of people who haven't been before, and I do recognize some who have, and so I think one of the positives going through these ideas, because there is a richness to them that hopefully you'll continue to have that opportunity to reflect, and for some of your own understandings to continue to develop. You know, this is from the classic book that many of us read when we were in our teacher's education program by John Vander Wal on teaching mathematics. And I think he really says it best, and he really asks us to check some of our intentions as teachers and some of the things we seem to do intuitively that might not always be as supportive of student thinking. Because no matter how patiently and clearly we explain, we cannot think and learn for our students. When we intervene too quickly in student thinking, we are actually robbing our students of the opportunity for learning. And I know we don't like to think of ourselves as doing that, but I've really reflected on that over time as some of my good intentions of this student is struggling, and looking at the difference and helping myself understand the importance of the productive struggle to their learning. Yeah, Matthew, that's absolutely, he does have a lot of posture with it. This is a taxonomy of engagement that we have developed at the Critical Thinking Consortium. And just for those of you who don't know, the Critical Thinking Consortium is a national not-for-profit organization that has been around for about 30 years. You know, it's had different phases of development. It actually started out in British Columbia. And it's a group of teachers and principals, superintendents, academics who've come together through the years. When people talk about critical thinking and how important critical thinking is, this isn't new. I mean, this was something that Socrates certainly talked about in Greece. So critical thinking, you know, when they say it's a 21st century skill, well, no, it's been a skill, or it's been a competency that's been needed for many, many, many years. But perhaps what might be new is that the importance of it's never been in some ways more important. So the consortium developed in order to really explicitly break down how do we explicitly teach this kind of quality thinking. And the taxonomy that's been developed looks at when we're engaging students, we want to differentiate between how are we engaging them. So sometimes our tasks just focus on that compliance. Like sometimes that feels like a good day. They're just on task doing, you know, what we've asked them to do or what task has been set out. I know that for many of us when we start out teaching and we have our teacher candidates, we're trying to entertain them. We're trying to be that engaging teacher that through our sheer enthusiasm and passion, through osmosis, we're going to get students engaged. And that certainly has its place, but might not be as sustainable and might not always have us address the core goals that we have. We like when students care or appreciate the value, but the real point at which we want to make sure we are targeting the kind of tasks is tasks that are truly challenging students and ultimately transforming them. So when we hear students say, you know, I didn't think of myself as a math person, and now I know that I'm able to persevere. You know, that kind of transformation, they become really challenged in a problem in the mathematical context. And we would argue that it's really through tasks that are explicitly surfacing and nurturing conceptual, creative, collaborative, and critical thinking that we're going to get those levels of engagement in students. This is something that was a study that was put out in 2009 from the Canadian Education Association. We're talking about engagement. And what I wanted to point out here is, especially when we start talking about inquiry-based mathematics versus also this dichotomy that's developed around, you know, the rote, and students don't always see the meaning in that, versus as well discovery and challenging this kind of false dichotomy that's been set up. What we really want to look at is critical inquiry, right? There's different kinds of inquiry and they have their place, but tonight I am focusing on a kind of critical inquiry. So when students don't have the skills or knowledge to engage in a challenge and they're not being challenged, they're going to feel very apathetic about their learning. If they have a high level of competence and they're not being challenged, they're going to get quite bored. Sometimes when we are challenging students, and this can sometimes happen in some of the ways we unintentionally set up inquiry tasks, but students don't have the necessary knowledge or skills, they can feel very apprehensive or anxious. And I do want to talk about this tonight because I also think that this is sometimes a stumbling block that teachers will say, well, I'm challenging students, but they need, you know, they have a gap in this knowledge, and so I need to cover that first before we do that. And I do want to talk about that a little bit tonight. The sweet spot that we're aiming for is that orange part on this chart, where students are developing the skills and knowledge needed while they are being appropriately challenged. And that's when students feel interested and successful in learning. And that's what we really want to go for. And what we also know is that students need to experience success about 20% of the time in order to stay with the task, right? And yeah, Matthew, it's a great point. That's exactly when we get knocked for being discovery teachers, right? Is that when that anxiety and apprehension kicks in. So I do want to address that tonight. And I want to invite everyone to take a moment right now, if you are either on your computer, if you've got some paper, if you're taking notes, I want to invite you to take a minute. Maybe Susan can just put a minute and a half, 1 minute and 30 seconds, to take some time right now and just answer this question for yourself, right? How might I effectively design and assess tasks to nurture quality thinking in mathematics? So take a moment, and I really want to invite you to do this, is take this time to put some of your initial thinking down around this question. Okay. And I want to thank you for doing that and putting some of those initial thoughts down. And we're going to come back to that as well as a structure. I think what we know to be true is that it is that focus on quality thinking that is the bridge to the deep understanding that we ultimately are trying to nurture in our students. And this is from a study done by Lauren Resnick in 1989. She's done some work around mathematical thinking. And this kind of takes us as well into this, the discourse around discovery versus rote. But what we know to be true, right, what research continues to point out is that becoming a good thinker in any domain is as much about the habits and dispositions of interpretation and sense-making as of acquiring any particular set of skills, strategies, or knowledge. Here's what I want to suggest. I want to share with you a shift in my stance as an educator that for me has really opened up some profound portals in the classroom, some exciting portals. And the shift in my stance is that I've moved away from being an accountant of expectations, which I found very uninspiring for myself and my students. And the shift I'm working on, and I've been working on for a number of years, is that I see my mathematics program as a program in nurturing the capacity in my students to think like mathematicians. And I do that through the various concepts and overall expectations for that grade level. So that shift has really opened up some powerful things that I hope to share tonight with you. So why should we focus on quality thinking? Why is this important? Well, critical thinking emphasizes the idea that math requires thinking for yourself, that we can help students develop those fundamental metacognitive and self-regulation skills that support learning. So thinking about their thinking, right? Actually thinking about their thinking. And when we focus on quality thinking, we have more options actually for adapting our instruction to meet the needs of students. So hopefully we'll look at some examples of that. So here's a little example from junior grade of a task, okay? And I want to invite you to think about what would be some criteria, some characteristics of the criteria for the best way to represent. So there's one of the mathematical processes, representing. Right? So what's the best way to represent a two-digit number to show its meaning? Thinking about how would you guide students, or what might they say about the best way? What's the best way to represent? I really welcome your ideas. Again, grab the mic, put some thoughts in the chat box. How might you help them understand the best way? Okay, so Stratis has said whatever way the child understands and can explain to others. Some other thoughts about the best way? Whatever makes sense to them. Okay, showing through numbers and words. So it's really interesting. We're talking about the best way. Some things that might surface, like, what's the context, right? Well, here we're asking for what's the best way to represent a two-digit number to show its meaning. So Matthew says, since 74 is an abstraction, the idea of a number, maybe then whatever way communicates the idea of 74-ness, the number line shows 74-ness spatially. Right? So some really interesting thinking, right? How do we show them, what's the meaning of 74? right? And how we are helping students conceptually understand a two-digit number, right? Looking at these different examples, right? And best absolutely always requires some kind of justification. So what we're going to get into as well tonight is looking at how we might use this criteria and the importance of it for nurturing that quality thinking. There are many definitions of critical thinking, and I'm certainly not asserting that this is the definition, but I do want to say that in my experience, this is one of the most pedagogically useful definitions of critical thinking, and one that as I've worked with it in my classroom has, again, really opened up some powerful entry points in my ability to support and nurture that thinking. So it's thinking through a problematic situation, right? Think about that question we just had about 74 in the best way. There's a problematic situation about what to believe or how to act, where the thinker is required to make a reasoned judgment that reflects the competent use of the intellectual tools for quality thinking. Okay? And we will unpack that. Right? We're making a reasoned judgment. We're going to look at those intellectual tools, because those intellectual tools are really, once we understand those tools and we are paying attention to those tools, then we have a really powerful framework for assessing and supporting student thinking. When we're thinking critically, we're doing so when we're judging or making choices among options in light of criteria. So going back to this question, there are multiple plausible options here. Not every option is the best option, but there are multiple plausible options. But it does require some justification, right, in order to support your thinking. And the criteria we're using here is best. What's the best way to represent? When we're creating that thinking classroom, it's a classroom where students are learning to think, but they're also thinking to learn. And this is where I want to challenge this idea about, this false dichotomy. One of the mismeanings of education is that we need to teach a bunch of stuff first, and then if we have time, we'll get students to think about it or apply it. And I want to challenge that, because I believe in order to really understand anything, we have to think about it, right? We have to think about it and understand it. So we can build that kind of background knowledge that's needed. We can certainly build fluency and flexibility and having certain things readily available to us. But that's more likely to happen when we genuinely, truly understand what it is. So to create that thinking classroom, we want to shape a climate that supports thinking in different ways, little ways, like things that you probably already do, for example, like think, pair, share. But what about if in your think, pair, share, if we bumped it up and what you did is you had students share their ideas, and then what they had to do is work with their ideas and create the best idea to then share with the class. Again, little ways that we can bump up thinking. We're creating opportunities for thinking through the kinds of tasks and questions we're giving to students. We're building student capacity to think, and we're providing guidance to inform thinking. And across the bottom are the 5 intellectual tools that are at play whenever we're thinking critically. So to enter into a challenge, so even think about the 74, that critical challenge that would be really well suited for a junior classroom. A student would need background knowledge to enter into that challenge, some degree of it. They need some criteria for judgment. In that case, it was best. Thinking vocabulary. This is both cross-disciplinary, the vocabulary of thinking that we might find across disciplines, like evidence, conclusion, observations. But it's also, I also want to invite us, it is also the mathematical thinking, conjecture, proof, that vocabulary that is needed, we need to explicitly be teaching that vocabulary to students to nurture and support their thinking. Thinking strategies are the thousands of ways in which we think through a challenge. A number line is a thinking strategy. A pro-con chart is a thinking strategy. A rating scale is a thinking strategy. There's thousands of heuristic devices that we use, that we already do that to support student thinking. And finally, we need to really be thinking in a quality way. There's certain habits of mind, and there's multiple habits of mind that we use across disciplines. We're talking about empathy as a habit of mind. The three most important habits of mind, I would say, in mathematics, not the only ones, but I would say the three most important, and the research supports this, are perseverance, that stamina to persevere through a challenge. This is something that I hear teachers say all the time in my work with them, right? It's that stamina and perseverance, and we've got to nurture that in students. Attention to detail, right? My colleague Laura Jeannie Newman was talking today about we have our students who flirt with perfection, and it's often those little details, right, that undermine them, right? That sometimes that carelessness, and in mathematics where you need to be so precise, and there is an unforgiving quality to it as well. And finally, it's that flexible mindedness and open-mindedness, being able to approach a problem from a different perspective, considering different ways in which to solve a problem, being able to make those connections. So those habits of mind are so critical to nurturing that thinking. And once we make these intellectual tools explicit, think about the power then of our interventions. That when a student is in our classroom and we can start to say, is the issue here in their challenge that they don't have sufficient background knowledge, and how can I intervene there? Are they using criteria when they're making their decision? That's about quality thinking, and this is what takes us out of sometimes, and I think in important ways, sometimes that is the realm of the discovery math that I think is problematic. Is it doesn't, like, students don't know what they don't know, and so by providing them with criteria, we are supporting the quality judgments, right? Not just opinions, but those quality judgments that are so fundamental. Right? Does a student need a thinking strategy? Would a number line be really, really important for them in this moment? Would a kind of organizer, maybe a fishbone of some kind, or some kind of organizer be supportive of them? Am I noticing that it's perseverance that's really standing in the way? And how do I really encourage that in them? So suddenly with these intellectual tools and using that as the framework, we can be more effective in supporting students, right, in the critical inquiry. Not just reverting back to, well, we just need to practice a bunch of the math facts and build that, and they're not ready to think. No, they are absolutely ready to think, but we need to be really intentional in the kind of classroom that we're creating and the way in which we're thinking about the tools that they're using, so that becomes the focus of our feedback. So if Calvin was your student, what would you say Calvin might need? Think about those intellectual tools for a moment. What might Calvin need? Feel free to write some thoughts in the chat box. Popsicle sticks. Yeah, maybe a few cubes or tiles. He needs some options. Maybe some of that, yeah, manipulative. You might also need some of the, like we're realizing, maybe some basic background knowledge in terms of a sense of proportion. Right? Being absolutely, and something to judge the reasonableness. But we see this, you know, I've put Calvin down, but we've all had, you know, in our classroom, like we have those moments where a student has written a really, and like the answers that really don't make sense, like there's not a reasonableness. And how do we support them? How do we scaffold them, right? How do we do that so that we are nurturing their capacities? When we're thinking critically in math, we are thinking like a mathematician. Right? Critical thinking in mathematics is not separate. Mathematicians, thinking the way a mathematician thinks is to think critically. So how can we bump up the critical thinking in any math task? So now I'd like to really get into some specifics about how we can take any question, so any part of your program, whether you are using a textbook right now, whether you have a particular unit task, whether the kind of questions you are going to engage with in your classroom. So I want to spend some time so that tonight you leave with a clear sense of the ways that you could take any question or task and tweak it and bump it up so that you're nurturing more of that quality thinking. So I'm going to ask you to look at these 3 questions. There's a slight little typo in the first, under type 1, the first box. It should be obviously where would you put them. So I just noticed that after the presentation was uploaded, so I apologize. But I want to ask you to, and please write in the chat box or grab your mic, what are the differences between the 3 types of questions that you see here? Okay, so some people are mentioning that type 1 is more of a closed question, very specific answer. So Satis, I'm asking, what are the most significant differences that you notice between the 3 types of questions? So in each column, the first column is what I call a type 1 question, and the type 2 a type 3. What are the differences between these 3 types? So someone's mentioned that the type 2 are more of a personal preference type of question. Olivia's mentioned that type 3 requires some reasoning, some proving, some arguing, more open. Naya has said, I hope I'm saying your name right. I don't know if it's me or Naya, but I think it's Naya. I apologize if I've mispronounced it. Okay, so and I want to say this as well. This is really important. I'm not going to say that any of these questions are bad questions. Like we're going to use all 3 of these types of questions in our classroom. But I think it is definitely worth paying attention to what it is we're asking students to do when we're asking a particular type of question. Because now we've got to get aligned with what it is we want them to do. Okay? So with type 1, there is a right answer. I affectionately call these where's Waldo questions, right? An answer exists. It's a matter of either knowing it through memory at this point or looking it up. There is an answer, or figuring it out. With type 2, these are the personal preference. There's no right or wrong, right? You can't be right or wrong. Do you enjoy finding patterns? No, you're wrong. No, right? There's no right or wrong here. With the type 3, those questions do invite some investigation. There's some curiosity that you need to engage with. There are multiple plausible options. Again, doesn't mean that every option is a good option or sound, but there isn't just one right answer here. So thinking about, in our classroom, what is the intention of the question? Sometimes you just want some recall in the moment. You want to find out if they know something, or you want to establish something. Or you do want to have a sense of the personal preference of your students. But when our intention is to nurture thinking, then the question needs to take a particular form. And when we understand that, and we understand the design of that, then again, we can take anything and immediately bump up the thinking for our students. So how can we translate this understanding of effective questions into setting up critical challenges, both large and small? And what I mean by that is, we can have unit-based sustained inquiry challenges, and we can have questions in whether we're consolidating or a question on an exit card, right? So large and small, we're thinking about our questions. And at the consortium, we spent time really looking at this and looking at the research, and we believe that there are 6, I think this is a pretty exhaustive list, there's 6 different ways that you can frame a critical thinking question. Okay, so we're going to look at these 6 ways, because I want you to leave with this in your own toolbox, that these 6 different ways that you could take a question. It takes some time. I just want to say that it really does take time to play with this and to revisit and to get this understanding of the 6 different prompts. But we're gonna start our journey. For some of you, you've been in this session with me, so this is some really good further consolidation. So one of the types of challenge is a critique the piece. So what I want to ask you to do is look at these 3 questions. And the definition is on the right. One of these is not an example of the critique the piece. I'd like you to tell me which one it is and tweak it so that it does become a critique the piece. Okay, and how would you, so some of you have identified, so how would you tweak it so that it does become a critique the piece? So Deanna, we're not comparing, what we're doing is, this is one example, critique the piece is one example of a critical challenge. I'm going to go through 6 different ways of framing a question that nurtures critical thinking, and critique the piece is one of the ways you can create a critical challenge for students. We call those kind of questions critical challenges. And the definition for critique the piece is would be on your right-hand side. Assess the merits or shortcomings of a person, product, or performance. And on the left, there's 3 examples, but one of them is not an example of a critique the piece. So you're trying to figure out which one. A number of people have said 3. And now I'd like to see, okay, Olivia's got an example. What type of data would be most useful to collect? Okay, so there we go. So we're tweaking it so it becomes a critique the piece. Right, so we're assessing something. There's our criteria: useful, how again useful is this data? There's some criteria. Okay, so I'm going to move on. If you need me to slow down, just please raise your hand so I know. Okay, Deanna, what piece are we? Okay, so Deanna, the 3 kinds of questions I have here are examples of critique the piece, except one of them is not in the form of a critique the piece. So people identified number 3, conduct a survey to gather useful data. You're not assessing the merits or shortcomings of a product in that instance. So if we were to tweak that to make it a critique the piece, we might say, determine whether the data we've gathered through the survey will be useful for our purposes, right? Or how useful will this data be in determining the favorite musical genre of the school? for example. So that question 3 right now is not an example of critique the piece, and we're trying to tweak it so that it is. We'll try it again with a second example and see if it becomes more clear. So another type of critical challenge is a judge the better or best. So here you're judging from 2 or more options which one meets the identified criteria. Okay, so again, so which one here would you say is not an example of judge the better or best? And again, if you've identified it, think about how you might tweak that so that it does become a judge the better or best. Yeah, so the issue with number 1 is you don't have 2 or more options there. It is a little trickier, Anik, you're right. So we might say something like, which of the patterns is more concise and accurate? Right? Or sorry, not patterns, which of the representations of the pattern is more concise and accurate? Which of these 3 representations of the pattern is more concise and accurate? Yeah, it does say show a more concise and accurate way, but we'll talk about that is a particular kind of critical challenge. You're so right, Anik, but in this case, the judge the better or best has to be among 2 or more options, right? Very great, Matthew. So decide whether a graph, table, or algebraic expression best suits the pattern. Yeah, or best represents this situation. Okay, so I'm going to move on again. If I'm going too fast, just flag me so I know. Third type, rework the piece. So Anik, what I think that example, number 1 from the previous slide, is an example of a rework the piece. So here we're transforming a product or performance in light of additional information or an assigned focus. So a number of you said number 2. Again, can you think about a way, this one's a bit tricky. Can you think about a way to tweak that so that it does become a rework the piece? Any thoughts? Yeah, definitely. It's definitely a tricky one. We might have to change the structure of the problem itself in a way. I want to give people enough think time. I don't want to rush too much because this is a good little challenge for us. It's getting us thinking. It could be something like you've been determining the probability of trucks, and so the reassigned focus, right? You know, to what extent is it likely that the next vehicle will be a car, right? Or reconsider the probability of a car passing in this situation, or a school bus passing in this situation. And again, so we want to be thinking about that criteria. You know, sometimes the criteria is implied in our questions, but again, being really intentional, I'd like you to pay attention. Like in the next, like tomorrow at school, in the next week, I want you to really think about where is the criteria in your questions. Let's do another one. Decode, another type of critical challenge. So here we're suggesting and justifying a proposed solution, explanation, or interpretation to a confusing or enigmatic situation. And again, thinking about if a number of you are identifying number 2, think about how you might tweak that so that it becomes a decode. And the reason number 2 is because there's no enigmatic situation, right? We've discovered the story pattern, right? Right. Okay, Jan, let's think of a way to increase the probability that the next vehicle will be a truck. And again, what I want to invite you to think about is what criteria the student's going to use to make their decision. So some really good thinking. And again, I just want to keep inviting us back to the importance of that criteria, because that's critical thinking from a pedagogical standpoint is criterial-based thinking, right? So with number 2, it could be use pattern blocks to effectively, or based on the pattern blocks, develop an effective explanation of the pattern of Goldilocks, right? So we actually have to figure out the pattern. There's an enigmatic situation there. Okay, let's move on to number 5, design to specifications or design to specs. So here we're developing a product that meets a given set of criteria or conditions. So which one of these 3 is not a design to specifications? And how would you tweak it so that it is? So in this case, what it is, the criteria is most suitable, but perhaps it's design a suitable non-standard unit for measuring a desk. Like that would be a really interesting challenge for kids, like to actually design their own non-standard unit. Like that could be very creative task or challenge for them to do that. That's number 3. And finally, the 6th kind of critical challenge. Okay, so I want to go back. So Anna, explain why a chosen non-standard is most suitable. So that is a critical challenge, but I would say that that is more of that. Well, would that be a design? Yeah, I mean, it's not quite a design to specs. They are communicating in the moment, but it's really more in this case, you've chosen something, there's more of a judge the better or best that's happening, right? But again, we're getting this familiarity with these different ways of framing a critical challenge. So with perform to specs, here we're performing or undertaking a course of action, and I like to think of this as something that happens like in real time, right? That meets a given set of criteria or conditions. So in this case, which example does not belong? So it's interesting that perform to specs can be a bit of a tricky one. Again, thinking about something that happens in real time, you can make a constructive contribution in real time, right? You are performing to specifications. You're making that constructive contribution. Which situation doesn't have a given set of criteria? Okay, so again, with number one, you're solving a problem, and as you're solving it, you are carefully monitoring your progress and adjusting your strategy. That is also something you are doing in real time using the criteria. Same with number two, but let's look at number three, right? When we're talking about performing the specification, create a story problem, okay, that would be solved by subtracting 24 from 53. Where is the criteria? Where's the criteria in number three? What's the course of action that meets the given set? Now, so I'm thinking about your thinking and probably saying, well, there's a condition. The condition is subtracting 24 from 53. But that is not really criteria. That's more of the requirement, right, of that problem. That's the numerical, but there's no real criteria in number three. You're not the specific, and that, so this is where we get into the nuance, right, of our critical challenges, and that's why it does take time to develop the understanding of them. And so I just want to affirm that, like, it really takes time and practice and really playing with them to really pull out and pull through these really good questions that are surfacing that thinking, right? Because subtracting 24 from 53 is not criteria. It is a requirement of this problem. Okay. We can talk a little bit more about that difference. So here are the attributes of critical thinking, of any critical thinking question or task. The task or question has to provide or generate options. They're either identifying or considering options. It does require that reasoned judgment. They need to arrive at the judgment or conclusion or decisions that are reasoned. It requires that use of criteria to make the judgment. Here's what I want to say about criteria and why it's so important in our questions. What criteria does is, in a beautiful way, by the inherent design of a critical thinking question, it forces reasoned judgment. I'm not saying that open-ended questions are bad. They're not bad. Open-ended questions have a different purpose. But when we're trying to nurture critical thinking, it's the criteria. If I said to you, I want you to construct a solution to this problem? Okay, that's very open-ended. But when I say I would like you to design an effective solution, and we unpack what effective means, and I'm going to show you in a moment an example from an anchor chart that hangs in my classroom. When I say an effective solution, and we've unpacked what effective means, then when a student is considering their solution, they now have the criteria by which they are deciding, oh, is this organized? For example, organized might be an element of an effective solution. Does this demonstrate deep conceptual understanding of the mathematics? Now we have created the condition through the task itself that is inviting the kind of thinking. Where if we said, I want you to construct a solution, we know that then in that anything goes, our students who are already perhaps thinking critically or using some dimension of quality thinking are going to do that, and our students who aren't, and how are we scaffolding them? How are we scaffolding all our students to get there? And a critical thinking task does require the use of evidence to support the judgment. See, when you say, well, this is an effective solution, what is your evidence? Point specifically to that evidence. Whereas when we're open-ended and say construct a solution to this problem, then is inherently, and this is what we know with a lot of students, the default criteria, and I put that in quotations, if you could see me, I've got my little bunny ears up right now, but what students revert to is that the right answer, this idea of the right answer. Of course accuracy is important, of course there's that unforgiving dimension of mathematics, but we also are trying to nurture a whole lot of other dimensions and competencies in mathematics. So these are those attributes. So you can see that through the design of an effective question, look at the kind of thinking that we are inviting and surfacing here. Let's turn to a moment to the metacognition, to the thinking about thinking. And for me, the three of the best prompts, and I sometimes create little cue cards for some of my students where, the productive struggle and trying to support them to engage in the productive struggle is really important. And Alan Schoenfeld, his 3 prompts for building that metacognition are quite straightforward, but very powerful. Having students ask themselves when they're solving a challenge, what are you doing? Why are you doing it? And how is it helping you? Okay, so the power of inviting students to think about those questions as they're solving. What are you doing right now? Why are you doing it? How is it helping you? Right? You can get these you can laminate like cue cards for your students of these prompts to build that metacognition in the mathematics classroom. And again, I want to just share with you 2 really simple ideas how you could tomorrow get in there and invite them to think critically. Does this answer, solution, strategy, approach, right, fill in the blank, make sense? Nurturing their capacity for determining sense making, for determining reasonableness, right? Going back to our friend Calvin there. Or which of these solutions, strategies, approaches is more or most effective? I just want to show you from the very simple way we can just take a question, but there's the criteria, right? And that this becomes our prompt. So when a student comes to me and says, is my answer right? So now I'm refusing to be the extended brain of my students. I'm really taking John Van de Waal seriously. And I will say to them a couple of things. I'll say, okay, I want you to convince me. Convince yourself before you convince me that your answer makes sense. Okay. Which of these strategies is most effective? So again, giving them options and deciding how powerful it is when we put up different solutions for students or strategies or approaches and get them using the criteria to make those judgments and internalize the criteria for an effective answer. Really, really powerful ways to build that in students. So we do not become the arbiters of an effective solution, but they as learners are really, really taking that on and assessing. I'm going to ask you to just take this time, just a minute, and revisit your initial thinking when you answered this question. To take a moment and just add to your thinking around this. How might I effectively design, assess, task to nurture quality thinking? Olivia has some great ideas. What made you say that? How do you know? So let's just take a minute to add to some ideas here. Absolutely. So triangulating our evidence, conversations and observations are critical to having that broader understanding of students' capacities. Right? Jane, great question. Is there a more effective way? Is there a more efficient way? Right? Another way of saying that. Is there a more elegant way? Sorry, I'm just going to just look at a common question, like when we're checking an answer, a common question we might ask is or are your statements or your answers correct? How can we take that question and tweak it for deeper thinking? Again, the role of the criteria. How do you know that your answer is reasonable? So we're building in them an understanding of reasonableness. What evidence or inference or clues allow you to state your answer with some certainty? Right? So if you're convinced that you are correct, what evidence, what's the most compelling evidence you can provide me that convinces me that your answer is correct? Right? Little ways that just bump up the thinking. This is the anchor chart that hangs in my classroom around an effective solution. And so students have been working with this. And so when they are crafting or designing a solution, now they're really thinking, is this organized? Is this accurate? Does it demonstrate? And we've spent time building this understanding of communicating a deep conceptual understanding, really not shying away from building and nurturing that mathematical vocabulary with students. What's a deep conceptual understanding? I want them to know. I want them to have an understanding of that. I want to share some examples before, as in our last sort of quarter here, just less than a quarter, or third actually. Where might critical inquiry lead us as teachers? So I want to look at some of the maybe unit tasks that we might use in our classrooms, some of the inquiry. So a quality mathematical thinker is engaging with all of these processes. So when we're thinking about the design of our unit tasks, we're trying to really explicitly surface and provide these opportunities for students to represent, to solve problems, to reason and prove. Maybe not all of them all at once, but to be really intentional again about which of these processes are we going to really focus on in the course of this particular critical inquiry. So this is a critical challenge that I developed for my students. This was in grade 8 mathematics around the surface area and volume of irregular shapes. So on the very first day, I put this image on the smartboard, and I give the students a thought book, and I ask them to develop a reasonable estimate for the surface area of the Guggenheim Museum. And sometimes I tweak this, and I've asked them to develop or design an elegant strategy for determining a reasonable estimate for the surface area of the Guggenheim Museum. And this, like you ask students and you just get them thinking, and they're like, well, first of all, I have no idea how I'm supposed to measure an irregular shape of a circle. For some of them, this is new. This is part of the, the curriculum expectations that they haven't encountered before. And they might do a little bit of inquiry and research into the Guggenheim and sort of talk about this as an architectural marvel. And just to get them speculating from day one to launch their learning and give them a meaningful hook for determining, for basically a meaningful hook for the kind of knowledge we want to build. And it's really exciting because I've noticed that as I've done this, as I've made more, I've shifted the design so that instead of that rich problem, like this might have been something I would give students at the end of a unit after we've built the background knowledge, we've understood, around how to determine the area of a circle and how to determine the volume and surface area of a cylinder. And then we give them the application if we have time. But this idea of moving that rich task to the beginning, to be the launch for the learning that you're going to do, is a really powerful way of enhancing student engagement. So rather than proof of learning, it becomes the driver of the learning. And the curriculum expectations cascade. This is a cascading critical challenge. The curriculum expectations cascade out from a very rich task that you can give students, right? And again, we've launched them. We've launched them into the learning. We've got them predicting, speculating, offering initial ideas, and not telling them, oh, that's right or wrong, just surfacing that thinking. And then we move into some learning. And we get students to revisit their initial thoughts, right? So here you have an example of a student, and this is her thought book, and you can see that she's grappling with this problem. She's considering it. She's making representations and trying to figure out how would I develop a reasonable estimate of the surface area of this irregular shape, right? And you see then that some of the learning that they do, right? They're learning about circles, and then they're asked, right, in their thought book, what's the most important connection between circles and the Guggenheim inquiry? Because in mathematics and the disciplinary thinking, you want them making those meaningful connections. So if they are doing a few pages or some questions from JUMP to sort of build some of that in the meaningful practice, they still have this challenge that they're engaged with. There's a purpose, right? There's a purpose to that learning and that practice because they're engaged with a larger challenge that's going to go on over several weeks, right? And this is an example from one of my students, and this is really special. His mom actually emailed me and said, I don't know what's happened, but my kid who's not liked math, he was working on this problem, and he was so proud of the work he was doing because he was caught up. So we go back to that taxonomy of engagement. He was so caught up in the challenge that, he really did, and he had a clear sense of the criteria, and it was nurturing and building. And earlier in the unit with this student, he had actually been quite resistant when accuracy was not the only way that he was evaluated, where there was this other criteria around an effective solution, and he was quite resistant. And we had some, there was that kind of conflict in the classroom, and I worked with him on that, and I spoke to his parents as well. And once he understood that and internalized it, you can see where he was able to take his thinking, right? You can see that where he was able to take his thinking and move in that direction, not just focus on the right answer, but engage in that thinking like a mathematician. When we're assessing, right, to kind of tie this back in, when we're assessing, we can use the tools as the lens for our assessment. So are students able to draw upon accurate and relevant mathematical information when they're engaged in this challenge? Are they making those reasoned judgments using the relevant criteria? Are they competently using key concepts that are related to mathematical thinking as they're communicating? Do they effectively employ useful strategies to work through the task? So, you can see, for example, the students representing visually the challenge. That's a thinking strategy, right? That representation is a form of a thinking strategy to help them think through the challenge. And the habits of mind, are they exhibiting those effective thinking dispositions that are needed for the task at hand? So the tools on the left, you can see, and we've put them in the mathematical context, become our assessment lens and the focus of the feedback we're going to give students. So the feedback is quite purposeful and quite connected to thinking itself. I'm here. Can everybody hear me? Okay, a little bit of a lag. Okay, great. Sorry. Okay, good. Sorry about that. I just saw as soon as you lost me. No, I was here. This is another challenge that I gave students. This was an enriched challenge in algebra, an intermediate algebra. Very first day. Oh, it sounds like I swallowed a balloon. That's terrible. Is it better now? Okay, good.
Yes.
So in algebra, very first day, the students are given this challenge, but the challenge isn't just to solve. It's to rank order the mathematical ideas or concepts from most to least important in arriving at an accurate solution. And then there were many challenges. So the students, there was, at first, like, we think about that original graph, the yellow graph, sorry, the orange, where from the Canadian Educational Association, where we're challenging them, but we're also building their capacity to engage in the challenge. So the very first day, students are like, whoa, how do I approach this? And some of them said to me, I think that only like 3 people are going to be able to solve this. But they get caught up in the challenge. And then we have many critical challenges around distributive property, around like terms, around integers. We bring back their knowledge of order of operations. So as they do that, they continue to revisit this challenge. And again, it was incredible to see the students ultimately being able to solve this in a really thoughtful way and build a deep conceptual understanding of like terms, of the distributive property, to consolidate their understanding of order of operations. So I want to just share with you the anticipation guide that was developed. So again, when we did the lesson on like terms, making it a critically thoughtful lesson, putting some key statements, and at first in groups, having students agree or disagree with the statements and build their justification. So you have to have students thinking, well, this is before they know anything about like terms, right? And they're talking in groups, you're surfacing thinking. Right away, you're getting them engaged in the learning. And then, through concept attainment, building the attributes of like terms through concept attainment, right? That like terms all have the same variable, they all have the same exponents, they all have a coefficient, right? They don't have to be of the same nature, the order of the variables doesn't matter. And then back to that anticipation guide, individually, and you can use this as a kind of exit ticket, those attributes become part of the justification, right? So they need to be using the attributes that you've built through this concept attainment strategy in their justification, right? So to really understand mathematics, students, the experiences with mathematics have to be consistent with the way mathematics is done by mathematicians. So what do successful mathematicians do? Well, here's some examples of some of the things that they do. So again, we're thinking about how do we intentionally provide opportunities for students to monitor their work and thinking for its meaning. How are we activating, utilizing, and building the schema, the background knowledge? What kinds of questions are we nurturing? What kinds of opportunities for drawing inferences? What kinds of opportunities for determining importance and considering relevant information? For creating sensory images or solving problems. This isn't an exhaustive list, but again, just some examples of the things that successful mathematicians do. So here's an example of some student work on that critical challenge, right? So for her, by the end, after we had done the learning, she determined that for her, order of operations, distributive property, and like terms were the three most important from the larger list that you see above. And then look at the language. That this is a grade 8 student building around mathematical justification, right? The kind of evidence, the reasoning, because now they've got to support that. There's a critical task. The top three, the three most important. What's your reasoning? What's your evidence for supporting your thinking on that? Right? And then actually teaching students about thinking like a mathematician so that they are, this student created this reflective list, because we also talk about in an effective solution there are some reflective dimensions, right? So the student is saying to themselves, well, yes, I've checked to make sure my answer is reasonable. I did that through substitution. I was thinking aloud about what was going on. I was using accurate math vocabulary to show my work. I was developing my purpose based on my prior knowledge. Right? This is absolutely possible with our students, is building their capacity to engage in these really meaningful and thoughtful ways with the discipline of mathematics. And again, the depth of understanding as they move to the next grade, for the intermediate teachers who are here, we know that that bridge from grade 7, 8 to grade 9, 10 is really critical. So that those deep conceptual understandings are so important. Here's a junior example of a critical challenge, right, where there's a lot of rich learning and curriculum expectations that are embedded here. So again, thinking about, where you can take students with this kind of challenge. So, when we're talking about growth mindset, which I know for, across many districts, the mathematical mindset is an important piece. It's in the safety of these classrooms that are fostering the growth mindset that students can begin to leave behind a fixed mindset and try out the idea that they can develop their abilities. In order to do that, we need to give students meaningful work, honest and helpful feedback, advice on future learning strategies, and opportunities to revise their work and show their learning. So thinking about how we frame those tasks, those critical inquiry tasks, are a really powerful way that we can do this, and using those intellectual tools as part of our feedback, creating that opportunity for engagement. And a student who really understands something this is what they're able to do. This is how we know that a student really understands. Not just through a test, right? But by the fact that they can explain it to us, that they could teach it to someone else, that they could assess it, that they could question it, that they could create it in a new way, that they could compare and contrast what they've learned, that they could combine it. So these are some of the ways we know when a student really, really understands something. So we want our tasks to provide opportunities for students to show their understanding in one or more of these ways. And finally, I did want to share, because there are a number of you who are your school board. If you go to our website, tc2.ca, you can find out if your board is a partner, because they have a list of partners. And if you're a partner, you can create an account and you have access to some of our free resources. But your account needs to have your board email address if your board is in fact a partner. If your board's not a partner, you can try to convince them to partner with us. Or for $40 a year, you can have access to the resources. And we do have some tools for thought. We have some lessons on nurturing critical thinking, and some that are specifically related to mathematics and science, as well as across different discipline, subject areas, and grade levels. And that you get behind the firewall when you have an account with us. Right? And we have some tools for thought on visualizing a math problem, analyzing a math problem and checking the solution, writing reflectively in math, monitoring problem-solving progress, organizing data in a table, and inference, which you can use with a mathematics example. So again, just using your, if you're a partner with us and you register, just please use your either, let's say Peel, use your Peel District School Board email address, because that's how our administrator knows that you're a partner board, and then that triggers you being able to access the resources for free. So I want to thank you and ask you too, if you have any questions at this point or comments, there's my email address, and I really do invite you, if you want to ask me some questions. I sometimes, speak to teachers over Skype and just to brainstorm and have some feedback. Also my Twitter handle, I'm happy to connect with you over that medium as well. And so I hope that you got some ideas. And again, tonight's intention was not just to give you some really practical ideas and tools to bump up thinking, but to give us a chance to reflect and be intentional in our practice about how we're nurturing that quality thinking in mathematics. So again, if there's any questions at this point, feel free to ask. I know that Susan has some things she would like you to do.
I'm just grateful that I have my microphone back. I was really struggling there. I lost all my privileges, so I had to log out and log back in. Anyway, I'm not going to take very long because you may want to talk to Maria rather than to me. But Maria, thank you very much. That was such a thought-provoking, rich session, and I know that participants hung around till 9 o'clock and had, you're hearing some good feedback right now. So thank you very much for bringing that. There's so much of what you said that's applicable across the curriculum. It's not just about math, but it's certainly, I really chuckled when you said that you thought back to your own math instruction as a student and thought that perhaps there was work that needed to be done, and I absolutely agree, and I think that this is such an important area. So thank you very much. I'm going to turn off the recording, and then I'll say a couple of things about other things. So thank you, everyone, for your participation as well. That was a really great night.